All right, let's continue here. Let's take a look at question number 12. Let's solve a quadratic equation here. The only thing that's different about these problems that's different from any of the factoring problems is now you actually have a solution for x. So if you look carefully at this guy right here, these are exactly the same kind of problems where you're looking for a product and sum. Can I find two numbers whose product is 56 and their sum is negative 15? So a couple of those tricks we talked about in class. If you have a positive C value and a negative B value, guarantee you will always have two negative numbers here. So I need two numbers that multiply to 56. Let me see. Let's try 7 and 8. I know 7 times 8 is 56. So that's the guess. The check is the outer and the inner. So x times negative 8 makes negative 8x. The inner, negative 7 times negative 7 times x makes negative 7x. Combine those together, you get negative 15x. Ooh, it's a match. We've got it. Okay? So now that we've got that, we're ready to continue. And so where we go from here now is something called the zero product property, right? That zero product property just is stating that if I had two numbers, any two numbers at all, and I multiply those together to be equal to 0, what must be true is that either A must have been 0 or B must have been 0. If I put some parentheses around this, it's really no different. A times B equals 0. That must mean that A must be 0 or B must be 0. Oh, look, I have two things right here. Think of that first group right there as being A, and then we're multiplying it by B, just like that. So then what we can do here is we can simply say that x minus 7 could be equal to 0, or x minus 8 could be equal to 0, and now we're just one algebra move away on each one of these cases of solving this algebra problem. Not too bad. So now I have two solutions here, x equals 7 and x equals the 8. Okay? Understand, this is one way we could have done the problem. If we had all the time in the world, we could solve this problem with the quadratic formula. Let's jump into a time machine and go there really quick. Whew, look at that. That was really fast. So, the quadratic formula can work here, but certainly takes a heck of a lot more time. A couple things I will say about that quadratic formula, and we're going to be doing it a little bit later too. But just remember, when you set that up properly here, make sure that you're successfully figuring out what that b squared minus 4ac is, which is just a 1 right there. Continuing on over here, where it gives us 15 plus the square root of 1, which is just 1. And then we can take 15 plus 1 divided by 2, 15 minus 1 divided by 2. Notice here we get the same answer that we had here of negative 8, and positive 8 and positive 7 that we would have had before. You see? Didn't we have this a heck of a long time ago? I can think of another fast way of doing this problem. We could have actually just graphed the thing. We could have typed in x squared minus 15x plus 56 into our graphing calculator. Got to look for the graph. Notice that it tells us that we should be looking for positive x's for our zeros. And sure enough, right there are two zeros for us. Oh look, 7 and an 8. Okay, the point of this whole thing is I don't care which way you do it. You got to know which way is most efficient to deal with the problem and go ahead and deal with it. I'm very interested in seeing that you guys can solve this many different ways. And so once again, just go ahead and have at it. Let's take a look at this problem right down here. Once again, certainly many different ways of solving this problem. What we're looking at is a modeling situation where a stone gets dropped from the edge of a vertical cliff. Because this is a quadratic function right here, a quadratic function or a graph, a parabola can model this one pretty easily. Taking a look at the situation, what we really have is this object being dropped from a height of 228 feet, and this object is falling. So what you can picture with that 228 feet is that's basically the y-intercept of this graph. And then what we actually have here is a parabola that just kind of does one of these in both directions. And so when it asks us this question of how long will it take for that stone to hit the ground, it's essentially just asking us when is the y going to be 0? Or, I'm sorry, For what value of x is the y going to be 0? There's a couple different ways you could solve this problem. Because of the way, and I guess I said x right there, I kind of mean to say t, right? Because we're dealing with time. At what time does that height reach 0? You can actually solve this problem algebraically. You've heard me mention this before. These quadratic situations in which we do not have a linear term, see we got a quadratic term of t squared, and we have a constant term of that 228, we're really just looking for when is that height going to be a 0. So we can solve this algebra problem by subtracting 228 from both sides. So negative 228, negative 16t squared. And now we divide both sides by negative 16. And by the magic of video editing, I can quickly tell you what that is. We have 14.25, 14 and a quarter, would be equal to t squared. Now how we solve for t is we will take the square root on both sides. Once again, video editing, work your magic. I get approximately t being equal to a plus or minus about 3.8, I believe. Think about what that plus and minus 3.38 means. It means right here, there's your 3.38, and then there's another one over here at, say, negative 3.38. But we aren't interested in this one because we're talking about time here. So how long does it take before it reaches the ground? 3.38. Oh, wait, I'm sorry. Look at the problem. Nearest hundredth of a second. So if we wanted to round this to the nearest hundredth, I think it was 3.77 seconds. That's how long it's going to take before it hits the ground. That's one way of doing it. I can think of another way you can do it. Couldn't we go to the graphing calculator, type in negative 16t, but in this case x squared, plus 228. Then we hit graph. Those are our two answers right there. Remember, the answer that we're interested in and when it's going to hit the ground would be this positive case where my mouse is. Can you see it? So I showed you how you can calculate that. We can hit second and then trace, and what we're looking for is a 0. So I press 2. It says left bound. You see right down there it says 0 and 228. It means I'm right there on the y-intercept. If I go to the right, see how the x is increasing? If I increase enough, we might actually see that cursor. Oh, I just saw it. I went past it. There it is. So left bound. Let's go closer to the y-intercept right there. That ought to do it. Press enter. See an arrow pops up, right bound. Let's go to the right side of where we think that 0 should be. Press enter again, and then there's that 3.77 right there, 3.77 seconds. You can use your graphing calculators to find that value pretty easily. Not too bad, right?